6.9 part 2. Okay, composition of functions. Composition of functions. What composition is when you're taking two things. Think of like when you're composing. A composer is someone who writes music. You can putting music together. This little circle is the same thing as writing this. These two things are equivalent. What this little circle means is you're composing one function, so in this case, the function of f, inside the other function. These are your two steps. It looks simple because there's two steps, but it can be very confusing of what goes into what. Now, the other thing you have to think about when you're composing is what's in the given. If the given is a number, your answer should be a number. So we're going to be doing both of these. If the given's a letter, your answer should have a letter in it. So first, this is the same thing as if I were to write g, the function of f, okay? So I'm going to take this on the inside out. So I'm going to look at just this. What this question first is telling me is that in the function of f, so right here's my function of f, plug in -3, because this is saying x is equal to -3. So if I look at my function of f, here's my function of f, it's -3 take away 5. So this is equal to -8. So this is the same thing as saying that this right here is equal to -8, because we just plugged that in and we got -8 out. So we can substitute those two for each other. So instead of writing this whole equation, I can write g and then -8. So now what this is saying, in my function of g, this is x is equal to -8. This is where you have to be careful because it's saying x squared. So this would be x squared, which is a positive 64. So this is my only answer. I plug -3 into my function of f. Then I plug that answer into my function of g. I want you to try to solve this one. Now, when I'm doing this one, this is rewritten like this. So your answer will not be the same because notice the first function here was the function of f. Here, the first function is the function of g. So pause the video and try to do it by yourself. You should have gotten that it is equal to 4. Okay, right there, 4. So you plug -3 into your function of g, you would have gotten a positive 9. This is now equal to 9. So instead of writing this whole function, I'm just writing 9. So 9 into the function of f, you get 4. Okay, so what now if I have an actual letter? So your answer should have that variable in it. So again, first I'm going to rewrite this right here. Now I'm going to focus on this inside first. My function of f. So one thing I tend to tell students is to write out the two functions right by the actual problem. So then you can see which function goes to what. It's saying this right here is on my inside. This is going to have a big box. This is on my inside, and this is our outside. Notice how when I do my outside, I'm not including the x squared. So first, this part right here, all this is telling me to do is rewrite this function in terms of a. So instead of having an x there, I'm going to have an a there. So this whole thing then, just like how this whole thing went inside of that equation right there, it's the same thinking process. So this goes inside of that equation. So when I put that inside, this g of x is saying x squared. This goes in place of your x. This whole thing goes in place of your x. Because what I'm actually putting in is that new equation. Plug a minus 5 in for x. So this right here would be my final answer. A minus 5, that quantity squared. So if I look at this one, this is in the function of g of x at x minus 2. So first, this part right here, so g of x is equal to x squared. Same, plug this into my function of g. So it looks like instead of having x, every place that there is written x, you write x minus 2. So now this is x minus 2 squared. So that is the same thing as this portion right here. This is that portion. So I can replace that with x minus 2 quantity squared. I get it. You're like, oh my gosh, this is hard. However, we will practice this. Now again, if I look at my function of f, my function of f typically is x minus 5. So this whole thing goes just into the x. So it's saying x, this replaces my x, so this is x minus 5. And this right here is my final answer. So question E is like question A and B. I can rewrite question A and B as a function G of 4. I want you to pause the video and try to do this one by yourself. And you should have got 256. So again, first I evaluate 4 into my function of G. So now this is equal to 16. So I can replace this whole thing with 16. Now if I plug 16 to the equation, 16 squared is 256. Here, if I rewrite this, this is in the function of f of the function of f. Now, because I'm not changing anything in this input, what I'm going to do is write down the function of f, because that's what's on the inside, and I'm going to write down the function of f, because that's on the outside as well, because it's the same function. Now, a lot of times you'll hear me say, do big box, little box. Whatever's on the inside gets the big box, because it's the whole thing is going inside there. Whatever on the outside function, so in this case, it's this function f, gets the little box just around the x. Now you're replacing those two boxes. So this, instead of having this box with this x, this is x minus 5, because you're replacing this box with the x minus 5. And then you're finishing off this equation. So this was the box minus 5. Now I can combine those two like terms. X minus 5, or minus 5 minus 5 is minus 10. So x minus 10. This whole backside we're going to do in class together. So from there, have a grand, have a wonderful day.